Okay, here we are on the scatter plot homework. We are looking at number 1, which we'll do together, and you'll do some of these on your own. So number 1, we have a graph of some kind of skill game. So basically, the hours you're playing the game is the x-axis. Your skill level at the game is the y-axis. And it seems obvious that it's definitely going uphill, right? These points are not a straight line, but they are showing an uphill trend. So I could say, as the hours played, x, increases, because x happens first, as the hours played increases, the game skill level also increases. So when they both increase, one increases, the other increases as well. That is a positive correlation. Now we're going to draw a trend line and use it to predict the game skill level of someone who played for 14 hours. So, I have my ruler. Let's go ahead and try to get, we have 1, 2, 3, 4, 5, 6. We might go through the middle of some of them, but the goal is to try to have about as many above as we do below. So here is 1, 2 below, and then here's a couple of above, and I'm going through that one. This one's below. So here's 1, 2, 3 below, 1, 2 above, and I'm going to go through that one, it looks like. Like I said before, yours might be slightly different. That's totally fine. It's a little bit of an estimate. Okay, so actually if I were to do it again, I might even change that a little bit, but it's decent, right? So based on my line, 14 hours would give me a skill level somewhere in this area, right? So maybe between 10 and 13. Between 10 and 13 skill level. And that's it. So you guys are going to do number 2 and 3 on your own. All right? Go ahead and do that. Same thing. Look at your notes that we did on the last video. Let's take a look at the bottom section. If the following data was graphed in a scatter plot, identify which of the following would have a positive, negative, or no trend. Remember, positive, as one goes up, the other one goes up. Negative, as one goes up, the other goes down. No trend is scattered. There is no possible up or down that you can tell. So, a person's shoe size and the length of their hair. Okay, well, you could cut your hair or you could grow your hair long no matter how big your shoe size is. So that is a no correlation. You could put no correlation. You could put none. Okay, the amount of chicken wings ordered as the number of guests at a party increases. Well, think about it. What's happening first? The guests at the party. The more guests at your party, you have more and more people, you're going to need more and more food. So as your guests is increasing this way, the amount of food you probably need to order is increasing as well. So I could say, you could easily argue that that is a positive correlation. Okay, the number of questions remaining on your homework assignment as you do your homework. Okay, so what two things are happening here? You're spending time doing your homework. Okay, that's happening first. Time doing homework. Number of questions. The longer, not the number of questions on the homework, the number of questions remaining, right? So the longer I'm doing my homework, say I don't do my homework at all. Well, all the questions are there, right? Then the longer I do the homework, I have fewer questions left to do. That's a downhill trend. The longer I'm working on my homework, the less I have left. So that would be a negative correlation. Okay? So you're going to do this one on your own, the amount of songs you download and the memory in your iPhone. I'm going to change that to the free memory, however much memory you have left in your iPhone. The number of members in a family and the size of the family's grocery bill. Think about that and tell me what that's going to be. You might give me a little sketch over here, mostly for yourself, to make sure you got that right. Okay, let's go to the back. We have identify the data sets as having a positive, negative, or no correlation. So more of the same, right? The number of hours a person has driven and the number of miles driven. Okay, well think about it. Time, we'd say, is almost always x, right? So the longer you've driven, the number of hours driven, the more hours I drive, the more miles I'm driving, right? So as this one increases, this one also increases. I'm going more hours of driving, I'm going to be going more miles. That's a positive correlation. Okay, the number of siblings a student has and the grade they have in math class. See, what's happening first? You can't even really tell what's happening first. Well, probably the siblings happens first, but you could have 10 siblings or no siblings. It's not probably going to affect your grade in math class. That's no correlation. Okay, the age of a car and the value of the car. Now, this is just a typical car. We're not talking about those like expensive classic cars that have been restored. We're not talking about that. We're just talking about the age of a typical car and the value. So it's common knowledge that as soon as you drive your car off the lot, if you buy it brand new, it drops in value several $1,000s. It's no longer brand new, right? So the older your car is, okay, the years old your car is, that happens first. And what's happening to the value? It's decreasing. Okay? A used car that's 10, 20 years old is a lot cheaper than a brand new car that's like this current year model, right? So this is a downhill trend. That is a negative correlation. Okay? You're going to do the next 11 through 15 on your own. Okay? I'll be walking around in class, and I'll be here for tutoring also. Okay, good luck.